Elements of research. Maybe. There we go. Elements of research. All research begins with a problem. A research problem is a question or issue that requires a response in the form of a structured scientific inquiry. Not all problems are research problems because not every problem can be studied according to the rules of scientific inquiry. As we have seen in the first chapter, the basic assumptions of science cannot be confirmed or disconfirmed empirically. Many questions are not grounded in identifiable and observable phenomena, and this is one of the things that you need to remember. One of the things I'm asking you to do is to come up with a research proposal, but just because a problem exists doesn't mean that we can study it. Not empirically grounded, will Western civilization disappear? That's not something that we could speculate about it, but we certainly cannot perform an experiment with it. Is the color blue nicer than green? First of all, we'd have to be able to define nicer. What is nice? Is blue nice, or is green nice? Or perhaps brown is nice. A unit of analysis refers to what will be studied and must be defined at the outset of the research project before data are collected and or analyzed. What is the researcher going to study? For example, depression, attempted and completed suicides, number of prescriptions of Xanax. These are things that we can measure. These are things we can analyze. A unit of observation refers to the unit that is afforded by a particular data set. So if we were looking for depression, we may be looking at statistics from a Beck's depression inventory. If we were looking at attempted and completed suicides, potentially our measurement would have to do with the number of completed and attempted suicides. The number of prescriptions of Xanax, how many pills are out there that we have been prescribed. These units of observation have to be things that we can measure numerically. I'm not talking, okay. Richard M. Medina wrote a paper analyzing 381 suspected terrorists and persons suspected of supporting terrorist organizations, as well as their ties. For example, their acquaintances, their friends. Medina's unit of analysis was terrorist networks, because Medina's contention was that terrorists and their supporters are not isolated actors. That was my drink. Medina saw terrorists and their supporters operating within larger networks or structures that are organized in highly patterned ways. Thus, what Medina studied was not the same as the unit afforded by the data that he analyzed. Individuals and ties between individuals as the units of observation. Once the researcher has decided on the unit of analysis appropriate to the problem being explored and the hypotheses to be tested, the research design, data collection methods, and data analysis decisions can be chosen accordingly. Abraham Kaplan called the process of selecting the units of analysis the locus problem. The locus problem is selecting the ultimate subject matter for inquiry. Ecological fallacy, distortions that arise from generalizing about individuals from the group. The NRA is a conservative organization, so each of its members must vote Republican. That's an ecological fallacy. One thing doesn't have anything to do with the other. Individualistic fallacy, distortions that arise from generalizing about a group from the individual. George has been caught sending letter bombs to liberal politicians, and he is a member of the VFW. The VFW must be a conservative terrorist organization. That's an individualistic fallacy. Variables in research are measured concepts. Research about Alzheimer's disease might look at age and gender as variables. Types of variables, there are three types of variables. The dependent variable, the variable that the researcher wants to explain. The independent variable, the variable that explains or induces the changes in the dependent variable. And the control variable, used to determine whether an observed association between independent and dependent variables is real. Now let me give you a quick example after I take a quick drink. And I talked about this in the last lecture. My own research had to do with suicide and resilience. So my dependent variable was resilience. My independent variable was what adds up to create resilience. I was trying to determine what creates resilience. And one of the things that I used, and of course, if I'm boring you with my same old story, I apologize, but one was gender. Are females more resilient than males? Age. Are older people more resilient than younger people? Education. Are more educated people more resilient than less educated people? Trauma is the more trauma that somebody experiences, the less resilient they will be. And my last had to do with culture. The stronger somebody's culture is, the stronger their resilience. Those were my 5 independent variables. And the dependent variable that I was looking at had to do with resilience. Continuous variables do not have a minimum sized unit by definition, no precise division. Length of time, education, age, gender, these don't change. These are continuous variables. Discrete variables have a minimum sized unit. One unit can be clearly differentiated from another. How much money do you have in the bank and in your bank account? How many children are in your family? Two variables are related when changes in the values of one systematically brings about changes in the values of the other. Covariation is when a connection exists between 2 or more variables. For example, the link between income levels and total years of schooling. More years of schooling leads to higher income. A faster jet pilot flies, the higher the g-forces are. Those are covariations. And this is the relationship between income and education. The more education you have, the more money you make. Dan has 16 years of schooling and he makes $35,000. Anne has 15 years and she makes $30,000. Marie has 14 years of schooling. She has 27. She makes $27,000 a year, and on and on. Direction, relations between variables are either positive or they're negative. Positive relations, when an independent variable increases, the dependent variable also increases. The negative or inverse relation, when the independent variable increases, the dependent variable decreases. Okay, and here is an example. The positive correlation would be when they go in the same direction. So if you study and studying and grades hopefully have a positive correlation. The more you study, the higher your grades are going to be. Heroin use and grades probably have a negative correlation. The more heroin you shoot up with, the lower your grades are. That's a negative correlation. The measure of the relationship between 2 items or variables, that is the correlation. The positive correlation, 2 variables increase together or decrease together. Example, the number of gallons of gas pumped is positively correlated to the amount spent on gasoline. Negative correlation, variables move in opposite direction. Examples, miles traveled is negatively correlated to the amount of gas left in your tank. The older a man gets, the less hair he has. Positive correlation implies direct relationship between 2 variables. Meditation increases the level of concentration. The magnitude of a relation is the extent to which variables covary positively or negatively. The highest magnitude of relation is a perfect relation in which knowledge of the value of one or more independent variables determines exactly the value of the dependent variable. At the other extreme is the lowest magnitude of relation, the zero relation, where no systematic covariation between the values of an independent variable and a dependent variable can be discerned. If a relation has no magnitude, it also has no direction. And that's what I found with my research, that age had nothing to do with resilience, that gender had nothing to do with resilience, that education had nothing to do with resilience. Strangely enough, trauma had nothing to do with resilience, and that was not my hypothesis. My hypothesis was that the more trauma someone suffered, the less resilient they would be, but that was not true in my sampling. The only thing that had a positive relationship was the level of culture. And I had an instrument that I measured culture with, and as that figure increased, so did resilience in the population that I was doing my research on. And there's a positive relationship. All of the dots go in the same direction. This is a negative correlation, and this is known as a scatter plot. And of course, this is no relationship at all. They're just all over the place. A research hypothesis is a tentative answer to a research problem expressed in a stated relationship between independent and dependent variables. The null hypothesis states there is no relationship between two variables. Now, this is really kind of interesting because you're going to have to write a research hypothesis, and your research hypothesis is going to be, in my case, my research hypothesis was that the population I was measuring would have a positive resilience, that the resilience would be strong. The null hypothesis was that the population that I was measuring would not have a strong resilience level. So the null hypothesis is what you're actually trying to prove. And the reason you're trying to prove your null hypothesis is because humans tend to be egocentric. Humans always want to be right. But as a scientist, we need to try to prove that we are wrong, that something is incorrect. The more that we work on these kinds of studies, the more likely that we are to discover that something is right or something doesn't work. And that's exactly what science is trying to prove. No matter how brilliant you think you are, one of the things that you should be doing when you're doing research is trying to prove that you are incorrect. And that's known as the null hypothesis. So you need to put together all the experiments you possibly can to prove that you were incorrect. And that's what the scientific method is all about. That's how we can prove that gravity exists. That's how we can prove that there are rings around Saturn. Without negative ideas or trying to prove ourselves wrong, we would still be thinking that the world was flat and that the sun revolved around the earth instead of the earth revolving around the sun. And that's important because that's the only way that we can prove that something actually exists using the scientific method. Four characteristics among all hypotheses. They must be clear, they must be specific, they must be testable with available methods, and they must be value-free. In other words, no value judgments. We cheat a lot. We do. As humans, we tend to cheat a lot. We want to seem as smart as we possibly can be. And of course, we do this by using value judgments. Let me see if I can come up with one. All Dene College students are smarter than all students from ASU. That's a value judgment. Why do I think that? I think that because my students are Dene College students and I'm their teacher and I'm really smart, therefore my students must be smarter than anybody else's. Well, that's a value judgment, of course. I do feel that my students are very intelligent, but of course, that would be a value judgment, and that we couldn't prove by hypotheses. And that's the end of the chapter. Okay, so next week we'll tackle chapter 4. So I'll see you next week.